Hi, this is Chad from Reichhardt Electronic Innovations, and I'm here with Mr. Josh Kistner. Josh has been working with us for a long time, and he is our quote-unquote PSR sprayer guidance expert. So I'm bringing him in to answer a few common questions that we deal with on different sprayer platforms. I have a list pulled up here, and we'll probably throw these in the comment section of the video. I'm going to go ahead and just go down the list here, and we'll touch on a little bit of this. The main purpose of the video is just to help address a lot of the common questions we get on Hagies and other model sprayers when we try to do PSR TAC row guidance. It's kind of a top-down list of what's the most common questions we get. And at the same time, I've queued up our object pool with the PSR system loaded up, and we can walk through some of these changes and some of these values on the screen. And then we may also have some pop-up images or videos that we'll throw on there as well, just to kind of provide a visual aid.
Absolutely. The other thing that can cause some of this, and we'll get into this a little bit deeper, because you can usually get this next one figured out before you even start trying to steer, is the middle position for your angle sensor calibration.
Okay.
And if your middle position is off, and middle is what we reference all the time for steering, and if your middle's off, then what we are trying to essentially get the wheels to steer back to is not a valid number, and the machine might hang to the left and to the right, or the right of the row, and then gradually come back to center, but then hang back off to left or right depending on how that calibration is done. But we'll get to that in a bit when we there's a good way to test to make sure that your center value is almost spot on without actually going into corn.
Okay, well, that sounds really good. So counting them on my hand here, but we have your valve, your angle sensor, those are the machine side things, those are the two biggies. And then in terms of settings, you have your TAC sensor calibration for neutral, you have your main sensitivity, and you have your TAC response. I would say if you were to list them in priority order, those would be the top 5, give or take the order, but those would be your top 5 ones that we address. So when we're dealing with performance, that's going to knock out most of the cases where we're dealing with performance or trying to acquire the best performance.
When do I need to adjust my wheel angle sensor versus trying to nudge?
Mm-hmm.
And this is always a big one, and this is a point where you can actually figure this out before you hit the field. And so where you can start is, first you make sure you have a properly calibrated neutral position for your sensors. You would then make sure that you have a proper speed source so that when you engage the system, it will move and engage. And then what you can do after that is go to the teach-in menu, do your wheel angle sensor calibration
For your middle position or your center position.
Yep. And make sure you do your left and right, of course.
Yep.
And get it to where you think center is as close as possible. And then what you can do is take it on the road or in your yard, and as soon as you're registering a valid speed, just engage the system. And what will happen is the wheels will point, the wheels will move to the calibrated center position. And if you notice the machine steering to the left, steering off to the right, then you know your middle position might be off, and you can go in to the teach-in menu, go back to your wheel angle sensor calibration, and then you can adjust your middle position, center position, and then repeat the process until the machine is tracking straight, not in corn, engaged.
Yep.
And this usually will help eliminate, do I need to adjust my wheel angle sensor versus do I need to try and nudge the system to compensate for my sensors being off?
Yep. No, that's perfect. And really, it's a good baseline thing to do. And the nice thing about it is you don't need to be in a cornfield to do this. You can do this anytime you install the system, make sure the sensors are hooked up. Neutral calibration of the sensor Calibrate center angle sensor. Make sure you have speed. Engage it. The wheel should point straight per the calibration. Make sure it tracks straight. And just one other thing to note on this too, it says center in this page. If you have older software, it's going to be a letter M for middle. That's why we keep crossing those terms. We've been using the term middle for probably 8 years, and now we're now saying center in the newer menus.
And the other point I'll point out here, Chad, too, is the other benefit you get is if your valve current's too high, your wheels will chatter in this process, and you'll know that you need to reduce that as well. And so it really covers quite a few topics without actually being in corn. It's probably one of the best setup and test procedures you can do for the system without actually being in corn.
Yeah, because we just talked about the 5 big items. You have your angle sensor, you have your valve, you have your TAC neutral calibration, and then beyond that you have your advanced TAC response, and you have your main sensitivity. So really, outside of TAC response and main sensitivity, which is something that you would adjust when you're actually in the cornfield, you can really get those other 3 items addressed out of the gate even before you get to a cornfield.
And then usually at that point you have those 3 things identified. Then it's usually just a matter of fine-tuning your other settings, which you can do. The system sensitivity, I should say, that one you can do engaged, going down the field, fine-tuning it, and then you'll find out, if I need to maybe dial back my sensitivity, increase my TAC response, things like that. But then you're just down to 2 variables instead of 5.
Yep. Just to start off the top of the list, common sprayer issues. The first question that we get, and we get this quite a bit, is with just general steering performance. And often what we see is either you'll see what's described as what we call a ping pong or slight weave of the machine within the row, between the rows of corn crop. And then comparing that with what we call a wheel chatter. And the best way I can describe that would be where the wheels are constantly working left and right, regardless of if it's in the center of the row or not. It's constantly busy, constantly active. Josh, maybe you have a little bit more to add regarding ping-ponging versus wheel chatter. And then also on top of that, how do we change things, or how do we address each of these?
Yeah, so the common question I get is in regards to performance and trying to describe the difference between that ping pong or a slow weave down the row versus a wheel chatter. Both are handled a little bit differently in the software and how to tune those things out. I would describe the ping pong or the slow weave as the machine, as it's going down the row, is slowly going from left to right, not necessarily going over into the next row, but never in the middle, staying where it needs to. Versus the wheel chatter, which you might see a slow weave in the field, but the wheels might be constantly moving back and forth very fast. You'd be either very slight movements or very large movements, but depending on certain sensitivity and all that. So usually how I try to go about trying to figure out which one is actually causing the problem is, if it's wheel chatter, it's usually the valve calibration is off. And what we mean by that is in the teach-in settings.
I'm going to go ahead and walk through that right now, Josh,
okay,
while we're doing that. Just so you're aware, to access these menus, you do have to put a PIN code in for the system, and refer to your install instructions on how to plug this information in and how to access it.
And so the valve calibration is in the teach-in menu, and if you have newer software, they are all labeled. It is letter D as in Delta in the teach-in menu. If you have older software, you will have another layer that you have to slide through and select the valve icon you see there. It is the same between the 2 software versions. Just this version has where everything pops up. So when you go into this valve calibration, you will have a left, a right, and a max. And the left and right are the minimum output that we send to the valve. And so where I usually start with sprayers is I want those wheels just barely turning. Those machines, especially when they start getting up to speed, tend to overcorrect if the valve current is too high. So usually less is more with these machines. And a common thing with the sprayers that I've seen is that left and right are usually not the same number. And so one is usually almost a percentage point higher. This is normal. We just want to make sure that they're moving about the same speed.
Okay, so you're saying left often has to be set higher, or the other way around?
Depends, because
On
if
the
machine, if they get hoses plumbed backwards, things like that, one might be. But usually left is higher.
Okay.
Right?
And the way you can tell probably is you go into the calibrate menu. And at this point, be aware that if you go in and do any of these calibrations, it can turn the wheels, so make sure that you have clearance to do so. It's a bit of a safety warning. But if you hit start, as soon as I hit start on the cal, or if you have older software, as soon as you go into that menu, it'll send a current or a signal to the valve to tell it to turn the wheels left. And right at this point, the wheels should start turning left if this value is set high enough. And then you can increase or decrease the output by hitting plus or minus. And your goal here would be to make sure that left and right are moving at the same speed. Is that fair to say?
Yes, same speed, and to start with, not moving very fast at all.
Okay.
Lock to lock in, I could argue even 30 seconds is too high most of the time for a sprayer. So usually just starting out with where those wheels are just barely moving is usually a really good start point for these machines.
What do you mean by lock to lock in 30 seconds?
The amount of time it takes to go from left to right or right to left, the full left, full right.
While at this minimum calibration?
Yes.
Okay,
Yep.
perfect. So you hit start. Say if you're in a left cal, you turn the wheels all the way to the right stop. You hit start and just time it.
Yes.
And see how fast it gets to go all the way to the other stop. And there's a such thing as having it too low as well?
Yes. If it's too low, that might actually cause that ping-ponging or the lazy weave that you see as takes too long to actually move the wheels when the auto steer is engaged.
Okay, so let's say we go through, do our calibrations, and we have a left at say 4.75, maybe a right's at 4.25. How about the max setting? Do you usually do much with max, or is that left alone?
Max, I don't usually touch. There have been cases where I do have to go down a little bit, as it seems to compound problems sometimes. If the machine is moving a little too much, and then if it does actually have to use that max value, sometimes it seems to overcorrect at that point. The lowest I've ever gone to help smooth out the wheels is 12%.
Okay. And just for everyone's awareness, the values that you see here, they're in percentage duty cycles from a center position. This is for a Danfoss ratio metric valve. You'll find these on 2012 or newer Hagie STS sprayers. You'll find them on Miller 5 or 6000 series sprayers, as well as some various other platforms. If you're dealing with other model machines, you may have, instead of percentage points, you may have milliamps. And that would be a very similar process, but the numbers are going to be a different numerical representation. And in addition to that, there's also a 30-second auto calibration that has to be run with those valve types. And we won't address that here, but that's just something to be aware of. Again, those are noted in the install instructions. So once you get your value set to where you want them, I hit the OK button, I save it. And now I get back out and I decide to run my auto steer. And while I'm running my auto steer, I'm watching those wheels. There's no chatter, but it's still got a little bit of a lazy ping pong, as you say. What would you do to address now that ping ponging, or it starts to have a slow sway in the field between the two rows?
Sure. So first thing I would absolutely do is first verify that I have done a proper neutral calibration, which would involve making sure the machine is not in corn, not touching anything, and making sure that those values are usually, a valid value is usually between 50 and 70. If you start getting above that, I would start looking at seeing if maybe that plate on the front of the sensor is bent, forcing the paddle back, and this would actually limit your range for steering and possibly cause some of this lazy weaving that you're seeing. So that would be the first thing. And if you go and look and say maybe your numbers are 50 across the board, nothing's bent, next thing I would actually start moving is the on-screen sensitivity, main screen sensitivity. And if it's still doing that lazy weave, I would try increasing it. And what you might find, and usually what you run into, is you'll get to a certain point where, say, maybe the machine is holding tighter to the center of the row, but it still might make some bigger jumps that make it appear to be weaving. So what you can do then at this point is determine, so maybe my sensitivity, my main screen sensitivity needs to be down a little bit farther. But then what I can do on top of that, and this would be available if you have newer software, is if you go into your TAC configuration menu, you have an advanced settings tab. And what you can do with this is further fine tune the actual response from the TAC sensors to the corn. And what you might find is you may have to run your overall sensitivity lower, but you might have to run up your TAC response. And vice versa if the machine is correcting too fast and almost mimicking that wheel chatter that would be mostly caused by the valve calibration. These things can compound themselves pretty fast. I would do this one step at a time, and that way you're not changing too many things at once to try and compensate for one or the other.
So 2 questions for you on this. In your experience, what have you found to be a common sensitivity value on different machines? And I know they vary from machine to machine. You have an idea of a general range that you've run into?
Yeah, so on Hagies, we usually will see between 50 and 70 with a decrease in the TAC response.
Okay.
And then on the Millers, usually it's between 15 and 30, and usually TAC response doesn't vary too much.
Okay. So on the Millers, you may have a TAC response in the 70% range or higher.
Yep.
And then on the Hagies, you're somewhere near closer to 50%.
Yeah.
Okay. And then it's an inverse response here, where you're maybe going with a higher sensitivity on the Hagies, but a lower sensitivity on the Millers.
Correct.
Okay. And the reason why we're listing Hagee and Miller specifically, these are the front boom sprayers. These are the ones that can, just by the nature of having a front boom, it's on top of the steering axle. It creates more of a challenge for guidance, especially road guidance, since we're guiding off of primarily the sensors. But that would be your big items there. We're talking about not too many settings. We'll address some additional ones here, looking at the notes here in front of me. But big ones are your valve current, and then you have your main sensitivity, and then you have your steering response. After that, there's additional settings. We'll touch on each of these a little bit. I see on my page here, the next thing listed below I have here is tilt compensation. And maybe you can shine a little bit more light on what you're describing with this.
Yeah, so what we've done out of necessity and trying to be able to sell this system to more than just the Midwest market, which is flat and straight corn rows, we have a tilt compensation module. It's a little white 2x3 box, and what that does is, and correct me if I'm wrong, is when you get on a hill, it essentially nudges the sensor input up the hill.
Yep.
Which then compensates for gravity trying to pull a machine down.
Yeah, it's essentially shifting the whole system. Yep.
And so you don't have to worry about this a whole lot until you start getting into very hilly fields. And at that point, we just need to make sure that the sensor is mounted correctly on the machine. And I'm sure we'll throw pictures and stuff in here. And then also making sure that a proper tilt calibration has been done. And then once those 2 things have been achieved, there's the tilt calibration, just following through the on-screen instructions in the install manual. And then once those things have been achieved, you can go into the advanced settings under the TAC configuration page, and you will have a roll angle, which would be your tilt compensation if you have a 2-axis terrain compensation. And I'm sure we'll throw some pictures and stuff in here.
Yep.
And then pitch doesn't affect we don't use pitch for TAC, do we?
Not too commonly. It has to do with when you're rolling up or down a hill. Your pitch angle will have more or less influence from roll based on if you're going up or down a hill. It limits the amount of compensation. And that has more to do with just things like wheel distribution and things like that. Or sorry, weight distribution. As far as roll angle is concerned, what are common values you run into? I'm seeing right now we have a default profile for Hagie sprayer in here. The default says 10%. Each tune set's going to have their own defaults, but this is definitely a value that the operator could go in and adjust based on preference.
Yeah, 10 to 20% is usually the norm. The highest I've ever had to see it go is 30. And these were extreme fields in terraces and hills, in which you could argue the operator couldn't even hand steer it. Extreme settings or extreme conditions like that. So
a couple other quick notes on the tilt sensor. Josh made mention of the external sensor. If you're using the iBox LT controller as we brand it, it's a silver box. It looks like a giant heat sink. It's got fins on the top. That controller is what uses the external terrain compensation. When we get to our newer generation controller, we're branding it the iBox MC. That's actually built inside of the controller. So at that point, it's really crucial that we mount the controller in a very specific orientation per the install instructions. The general process, though, is the same. You have the same advanced setting, the same value, and it's the same calibration procedure in the teach-in menu. The only difference is if you're using an internal, like an MC that I have here at my desk, you have a position value which is based on the orientation of the controller mount. If you're using an external tilt, it's always with the label facing up and the connector facing to the left. And we'll pop up some pictures, or we can show some stuff in some installation instructions at some point.
And so while we're on this topic, if you get back into our advanced TAC settings.
Yep.
The other one that has some influence is the gyro stabilization. I will say that I don't necessarily use this a whole lot unless you're trying to steer. If that machine's moving quite a bit, it can really introduce a lot of movement, and the gyro stabilization is supposed to help smooth some of that out. Yeah. What I will say is if you start increasing your roll angle and your gyro stabilization, you are actually taking away from the influence of the TAC sensors. And so I wouldn't make these numbers too extreme. Or you will notice, I would almost call it, you would introduce a lazy weave at that point, since you're going less off of the TAC sensors and more off of the gyro and the tilt sensor.
That's perfect. And actually, I got something queued up here. It's out of an install manual. I'll just go ahead and pull this up. If you can see here, this is an older install manual for an Hagie STS, and it's got the LT box. It's further up here, but what I want to show here is at the bottom. This is a picture of our tilt sensor, top view down, and then you have the connector that should be going out towards the left. And then up above here is the gyro. That just measures rotational acceleration. We need to make sure that's mounted solid to a flat level surface. And at that point, we just need to make sure that the magnet is on the bottom. And that'll just tell us when we're turning right or left. And we use that information both for GPS steering as well as if we're doing road guidance and we're adding influence with this gyro stabilization value. If gyro stabilization set to 0, you in fact would not even need the gyro connected to run it unless you're doing GPS steering as well.
So I think that covers the advanced settings and how to identify that weave. I think we're going to break down a couple more of these to further get into diagnosing some other problems.
Okay. Addressing Combi Mode, we talked a little bit about different steering modes. You have your straight, curves, and Combi. And as far as Combi is concerned, it has advantages and disadvantages. The current state of Combi Mode, we're actively looking to overall improve the mode to be more flexible for more applications. What situations do you see it usable, and then what situations do you say you probably want to just guide off of rows and count your rows? Would it have to do mostly with you said your headlands, you need to have enough room to do a full turnaround and have room to line acquire with GPS. If you can't line acquire with GPS in the amount of time before you get back to the crop, it will not be successful. If you are stopping and filling, there is a timeout currently in Combi Mode which will not allow it to maintain and store that line, which means you'll lose that line, which means you'll have to manually drive to the next pass after filling, or drive back to the next pass after filling. Those are kind of two of the main ones. If you have point rows that are, or headlands that are not tangent or 90 degree, you may find that it line acquires well before you get to the crop, and then it'll switch to TAC sensors, and it's not reading off the rows of crop, it's reading off of the headlands when you're in a sprayer, and it's not going to be successful. And vice versa, if you're turning up into the point row where you have a much shallower headland, you may not line acquire in time, and in the same situation there, you might be GPS guiding down the rows longer than you'd like to, and you'd rather just switch to TAC steering right away. So those are some of the shortfalls with it. For guys that operate and use it, they definitely have a benefit from it, but I would add to that though, and Josh already mentioned that earlier, but the system needs to be steered for GPS. If it's not steered for GPS properly, Combi Mode will not be successful. I would argue it's a walk before you run kind of thing. Make sure your GPS steering is rock solid, number one. Make sure your TAC steering is rock solid, number two. If both of those are working really, really well, then you can discuss the idea of adding in Combi Mode. But it is by definition an advanced setting that it doesn't fit all, and need to definitely address the shortcomings where it fits and where it doesn't.
Well said. The only thing I can really point out, the other popular sprayer we do would be the newer Miller New Holland Guardian sprayers, where they are can steered, so there is no valve calibration. And the only things that you can tune at that point are the main screen sensitivity and the advanced settings. And so we have been able to find a nice fine line between those, essentially following the same guidelines as the 5 and 6000 series,
okay.
Other than you can almost eliminate the valve calibration. However, there is a machine side calibration that does need to be done.
Mm-hmm.
And a wheeling wheel sensor calibration on the machine side that needs to be done.
Actually, touching on the Miller, I'm going to go ahead and just dive in. Do you recall offhand like a vehicle code for a Miller?
Which one?
7000.
It's a 4...
Putting you on the spot.
It's a 4... 3...
364? Yeah.
364, yeah, because RGC is 374.
Yeah. By the way, you don't have to name this. I just do this for my own sanity. It's a good reference at least. So I got a Miller 7XX. We changed this to a vehicle code 4. So now we're pretending we're in a Miller sprayer. 364, and this third box is your valve preset. We don't have a valve. CANBUS controlled. We save it, and you're going to notice once this is saved, you notice the valve calibration icon went away. So that one tool in the toolbox for fine tuning now has gone away. That's all handled on the machine side. There's a machine side calibration for the valve, which means now we just have our angle sensor, your TAC calibration for neutral, and then beyond that, your additional sliders and your main screen sensitivity. So one less thing to tune. So it's really important that we have everything calibrated right from the machine side. If you still see chatter, things like that, this would be where you would want to look at the machine side calibrations of the valve. We'll just go ahead and we're going to throw up some pictures here so you kind of have an idea what we're talking about. You'll see that here's the first image. You can see that the plate on the front of the sensor, this is a return from a customer unit. Notice how the front plate has a nice curve to it. And this is not acceptable. What this is going to create is an instance where now when this is fastened securely to the sensor, the paddles get pushed back, and now our neutral reading might go from say 50 up to maybe 80, 90. I've seen it north of 100 counts. And the full working resolution of the sensors when you press it all the way up against the sensor only goes up to 450. And let's say you're in 30-inch corn, they may only have readings that go up to 130, 140. So If we have a neutral calibration of 110 and you can only go up 30 when you're pressed in all the way to the sensor, you have really no chance of having success at that point because you don't have any resolution. We don't have anything to respond to. So it's really important that this is addressed. Your neutral value should be somewhere around 50. And I'm going to go ahead and page over because I have some other screenshots I took. This is the curved plate connected at my desk, and you can see here I have a neutral reading of 117 and 94. That will not run in any normal scenario. So it's really important that those are addressed and replaced with a different front plate. So you can see when I press them in all the way, it's 450.
And I'll add, if your neutral readings are that high, this will normally introduce, I wouldn't say it's even a lazy weave. What you'll notice is the machine will hunt. Mm-hmm. And it will go all the way to the right until it sees extreme readings, and then it will bounce all the way to the left, and depending on how your other settings are set up, it will jump a row. It will overcorrect and jump a row.
Okay, so that's a really important thing to point out. Another thing that we run into quite a bit, and I'll just go ahead and pull up a picture of this. We had a return sensor that came to us, and you notice there's an indentation in the TAC sensor, and this one was returned to us, and this is a red flag for me right away. You notice that there's dirt packed into this indentation. This suggests to me that the sensor actually wasn't in the proper orientation. Where that nub on the sensor, I'll go ahead and pull up the document here, right here, that nub needs to line up with the sensor. And from what I'm seeing right here, that was not the case. And in fact, I could tell really quickly because if I look at the sensor that was also returned, you can see how this is pressed inward. That's because it was pushed up against a flush surface. What that means is the sensor is upside down. And you know what that leads to?
The paddle was upside down.
The paddle is upside down, thank you. And when the paddle's upside down, you'll notice that here's a good example. If this paddle is in the proper nub and I press the paddle all the way in on left and right, I have readings of 450. But if I have the paddle upside down in the exact same position, now you notice the readings. They're down to 250 and 263. So this still appears like a working sensor, but now you get half the readings, or nearly half the readings. And now you've also lost additional resolution. So the combination of a bent front plate and or having your TAC paddle upside down, both of these can cause a really big problem for the system. The easy way to check these, check your neutral reading, make sure they're around 50. They have a little curl to them, that's okay. Not to the front plate, but to the paddle themselves. Because of the built-in memory in the fiberglass within the sensor.
Normal neutral readings when you have a system that's been in the field for a season or two, I'd usually say it's between 50 and 70.
Okay, perfect. And then as far as the max reading, you can also test that. Push the sensor all the way up against the setting to the sensor. Push the paddle all the way up to the sensor, and you should have a reading of about 450. This is a normal, healthy reading pressed in all the way. And again, yeah, neutral shouldn't be that high. It should be about 50.
And if you see odd readings that are below 50 or above 450, you have a wire that is shorting somewhere.
Yeah. Also, for reference on your TAC readings, I have a TAC sensor hooked up. I only have one sensor at my desk, but here you can see TAC 1, TAC 2, and I can actually move these sensors in. So for example, let's say there's a little curl to it. Right now I'm holding it upright, so they're kind of hanging a little bit. Now they're in the mid 50s, upper 50s. If I press in all the way on the left, you see it goes up to 448, close to 450. Press in on the right, 447. And if you have a sprayer, most times the sprayers, you're going to have two sensors, so you're going to have 4 inputs, reading left to right, 1, 2, 3, 4. That's another very important point, and you would have no chance of success, but if for any reason either of these sensors are upside down, for example, TAC 1 and TAC 2 are swapped, or TAC 3 and TAC 4 are swapped, it's going to think right is left and left is right. You will not be able to successfully steer. That's not even a tuning thing. It would engage in steer off past the corn very quickly. So regarding the height of the sensor, how tall does the sensor need to be?
Usually what we see is about 15 to 18 inches off the ground is usually about as low as I'd go.
Okay.
We do have some operators who run a little bit slower, run their own fields that will run it lower so that they can get into an earlier stage crop.
Okay.
Most custom applicators will not run it that low as they don't know some of the field conditions.
Okay.
So 15 to 18 inches minimum. If you're starting to go in corn that's hitting your windshield, you can bring it up a little bit higher.
Okay. Well, that sounds really good.
And then the other one I get asked is if my sensor's not mounted centered on the row, how much will that affect my steering? And the answer is it will affect it a lot. All these sensors have to go on is where the corn was planted, and if your sensor is not centered in the row, say one of them's an inch off, well, you're going to get a weave because it thinks that the center of the row is supposed to be over here, and your sensor is mounted over here. Your middle position is calibrated here, and it's gonna fight itself going down the row.
No, that makes sense. And then if you have two sensors like you do on most sprayers, it's going to try to split the difference, but it is constantly fighting itself. And you can just argue, how accurate do you want to be in the field? Do you want to be as accurate as possible? Well, if you're an inch off with your sensor mounting, you're going to be an inch off in the field. You can compensate with things like nudging or other compensation, but that only is going to get you so far.
Pitch is always the other one I get. Well, how, can I have the sensor angled up so that maybe it doesn't slide back so easily on that bar?
Oh.
Right? And I'd say you're safe to a point, but I would try to get it to where that sensor is as square to the machine as possible.
Yep.
Any pitch would skew your readings coming in because that paddle's not going to be able to move efficiently. It might have some unwelcomed resistance, or it might not even move correctly because you're not hitting that paddle square.
Yep. Yeah, it definitely could bend back in a different kind of shape. This was designed to hit the corn crop perpendicular to the crop, so it bends straight back. But that said, yes, we've had circumstances where it's been necessary, and it's just a matter of everything in moderation, I guess is one way to put it. More and more often now, especially the last handful of years, we've been going with instead of a frame mount for the TAC sensors, we've gone to a wheel mount or a crop divider mount typically. Yep. Are there any tips or comments you'd like to make regarding mounting to a crop divider, and anything in regards to like forward, backwards, those kind of things?
Yeah, so the crop divider that we've been moving is made by HFL Fabrication in Ontario, Canada. And how the divider mounts to the machine is usually by a specialized plate, and then how the sensor mounts to the crop divider is there's a round bar in the center of the divider, and then there's a clamp that mounts the TAC sensor on its post for adjusting height to this bar. And what we've seen recently, and this can happen, is if you mount the sensor with the post facing the front tire, so as in the sensor is now actually kind of behind that bar, what we're seeing is the paddle is actually now behind where the divider starts to square up. It's actually at its widest point. Okay. And what's happening is as your machine's going down the field, if it needs to make bigger adjustments, say for terrain, things not being adjusted correctly, what you're fighting is now there's a chance that the crop divider itself is actually pushing over the corn before the sensor can read it. And what that will do is that will make the machine it'll steer off one way, get off, and then it will keep going that way until it eventually either jumps a row because the divider pushed the corn over too far and the sensor couldn't read it, or you'll get that ping pong effect where the sensor or the machine will guide down the row and do a weave because that crop divider is pushing the corn over before the sensor can read it. And so the fix for this actually has been to mount the bar facing the nose of the divider with the TAC sensor at its farthest point that it can be on this bar, and then it is not behind, I shouldn't say, it's not trying to read crop at the widest part of that crop divider.
Gotcha. So if I'm looking at this picture right now, we want to make sure that this sensor is as far forward as possible.
Yes.
So if you have a crossbar here, and I don't think I have a good picture here to pull off of, but we want to make sure it's on the front part.
That first one on the left. Nope, down. There you go.
Right here? Okay, perfect. Let's see if I'll get a good side view here. That's not the best angle,
But you can see, actually, if you zoom out, you can see back here that this crop divider is in front of the widest point.
Okay.
But when that crop divider is behind,
Yep.
and if you have it mounted where the sensor is even facing the other way on this post, then you're well behind where the widest point on this divider is.
Okay.
And that will decrease your chance of success.
Yeah. So the main point on this is we need to make sure that this TAC sensor is far enough forward on a crop divider mount so that we're not reading what the crop divider is pushing back, we're reading the actual crop in the field.
Correct.
So really important point on this regarding mounting is make sure that this is far enough forward, especially when you're doing a crop divider mount. And then we already addressed the height, and then we talked a little bit about pitch. I see here in this picture we're mounting it to the top of the bracket. I've also seen where the sensor is mounted to the bottom of the bracket.
I would recommend mounting it to the top of the bracket just for added protection.
Okay.
If you hit a hole, if you're in a field where the field conditions aren't the greatest, that way that the bottom of the sensor has no way of directly coming in contact with, say, a rock, something where it'll contact the bottom of the sensor itself.
Okay, and that sounds good. And maybe the last picture is probably a better idea or better way of showing it. But if you look at the bracket, you'll notice that it actually follows the outer contour of the TAC sensor, and that actually allows the trash, anything to fall through and not build up on the sensor. I also know that you will get some buildup on the sensor, but it typically, as long as it's not affecting the performance, and you'll know pretty quickly if it is affecting the performance, it shouldn't be a major concern at that point. All right, no, that sounds really good. Those are really good points, Josh. Thank you for adding those. But just do a quick review. You have your 5 main settings. So you have your valve calibration, angle sensor calibration, TAC sensor neutral calibration, make sure the readings are good and in the correct order, and they have good working range. And then after that, you have your tuning adjustments for your main sensitivity and your TAC response. After that, we have things like tilt compensation, make sure that's properly calibrated and set, as well as the advanced setting for tilt comp. And then you have your gyro compensation, and we just want to make sure the gyro is mounted in the proper orientation, and there's again an adjustment for that. Those are the big ones. And then after that, it's just touching on the different modes and things like Combi Mode, when it can and can't be used. The nice thing about this TAC system, there's not a whole lot that can go wrong with it, so it's a short list. Beyond that, then there are background settings to our system. It depends on what vehicle or what machine you're putting this on. So for example, if you put this on a Hagee sprayer, there's going to be preferred vehicle code, default tune set information. I'm not going to go into details, I don't think, for this video, but that would be one thing to address, is make sure you have the right vehicle code entered. And then same thing with a Miller sprayer or any of the other sprayer models. If you're doing road guides, you want to make sure you have the right profile put in. That can be a common problem, is if we have the wrong profile, it's going to try to tune it like it's a different type of machine. It's not going to be successful. So first and foremost, let's make sure you have that right vehicle code put in. And then after that, we can adjust those main 5 items and address those at first, as well as then your tilt and your gyro. And then beyond that, the mounting of the sensor, your height, the proper mounting in terms of spacing between the sensors, make sure it's, measure twice, cut once kind of thing. And I think with that, I think those have tackled most of the biggest points. You got newer, older Millers, you got your Hagees, and we talked about settings. I think it's probably a good break point. Thank you guys very much for listening, and we'll talk to you again soon.